Hello students, 7b-5 is solving quadratic equations from real life problems. So I know we've done a few of these, but I want to clarify a few things in this video just to help you be more confident in solving quadratic equations when they're given to us in word problems. So let's look at number one. You'll notice that this is your independent practice, so I'm going to do a couple of these together with you. If I do the complete problem, then you cannot count it as one of yours, but if I stop halfway through, then you can count it as one of your 5 that you have to do for this practice. So let's look at number one, softball. Olympic softball gold medalist Michelle Smith pitches a curveball with a speed of 64 feet per second. If she throws a ball straight upward at this speed, the ball's height h in feet after t seconds is given by h equals negative 16t squared plus 64t. How long will it take the ball to reach the ground? So if she throws the ball straight up, how long will it take to reach the ground? Well, to reach the ground, what is the height? Exactly. When I hit the ground, the height is going to be 0. So at the ground, h equals 0. So I need to plug in 0 for h to be able to solve this. So we get 0 equals negative 16t squared plus 64t. 64t. And now I want to solve this. Well, the first thing I want to do is get rid of that negative. So I'm going to divide everything by negative 16. Okay? Let's get rid of divide everything by negative 16. And so 0 equals t squared minus 4t. And you're thinking, well, why didn't you pull out the t? Because that was the greatest common factor. Because if we did that, it wouldn't work the way we needed it to work. Okay? So now I've got 0 equals t squared minus 4t, and I want to complete the square, because that's probably the simplest or the most efficient way to solve this one. So to complete the square, I know I have to take half of b, which would be negative 2, and square it, which would be positive 4. So I'm going to add 4 to both sides. That gives me 4 equals t squared minus 4t plus 4. Okay? So now I need to factor the trinomial. So 4 equals t minus 2 squared. Okay, that's nothing right there. And now I want to find the square root of both sides. So I do the square root of 4 equals the square root of t minus 2 squared. So this is going to be plus or minus 2 equals t minus 2. Move the 2 to the other side. T equals 2 plus or minus 2. So I know that t equals either 2 plus 2 is 4 or 2 minus 2 is 0. Well, I know it can't be 0 because we know she threw the ball, so it had to travel at least some amount of time in order to get to the ground. So the answer is t equals 4. 4 seconds for the ball to hit the ground. So anytime we're looking at something hitting the ground, we plug in 0 for the height, or if it tells us some other height, then we would plug that in. Okay? So now let's look at another one. Let's look at number 3. Okay? In number 3, it says at liftoff, the Space Shuttle Discovery has a constant acceleration of 16.4 feet per second squared and an initial velocity of 1341 feet per second due to the rotation of the Earth. The distance Discovery has traveled t seconds after liftoff is given by the equation d of t equals 1341t plus 8.2t squared. How long after liftoff has the Discovery traveled 40,000 feet? Round your answer to the nearest tenth. When it says round your answer to the nearest tenth, that gives me a hint that I'm probably going to have to use the quadratic formula. Because typically that's the only time we ever round is when you're using the quadratic formula or finding the square root of both sides, but I wouldn't try that on this one. So let's use the quadratic formula. First we have to set up the equation. It says that traveled 40,000 feet, that's got to be a distance. So we know that 40,000 equals 1341t, plus 8.2t squared. So now, let's put it in a form that we can more understand. So I'm going to put it in standard form, and I'm going to leave 8.2t squared on this side, but I'm going to just do 8.2t squared plus 1341t minus 40,000 equals 0. Okay? Now, because I just encourage you to use the quadratic formula, I'm going to stop here and I'm going to let you finish this problem using the quadratic formula, and you can count that as one of your 5. So pick out A, B, and C, sorry for that little mess right there, and then use the quadratic formula. So let's look at a couple in the back. The first one on the back we're going to look at is number 7, because why not? Lucky number 7. Okay, number 7 is number theory. I know this trips up a lot of people, not y'all, but a lot of people, so let's go over it. The product of two consecutive even integers is 440. Find the integers. Okay, so, well, I know that my first integer is going to be x. Now, to get to the next even number, what do I have to do to x? You're right, I have to add 2 to the x. So my second integer is going to be x plus 2, because I have to take that original number, add 2 to it to get to the next even number. That's exactly the same way it is with odd numbers. You start with x, and then you have to add 2 to get to the next odd number. Hint, hint. So now it says the product of those, so I have to multiply them, x times x plus 2 equals 440. Okay, so let's use distributive property. X squared plus 2x equals 440. You have several choices. You could complete the square if you wanted to, or you could factor it, or you could use the quadratic formula. I'm going to factor this one. So I'm going to do x squared plus 2x minus 440 equals 0. Now you look at 440 and you think, what are two factors? Well, it looks like 20 could go into 440 because 2 goes into 44 22 times. So 20 goes into 440 22 times. So we know that 2 is positive, so that means the larger number has to be positive. So we're going to do x plus 22 times x minus 20 equals 0. And those are my two factors of negative 440 that add up to positive 2. So I know that x equals negative 22 or 20. If x equals negative 22, then the next even integer is negative 20. So my first set could be negative 22 and negative 20. Or if x equals 20, then my next even integer is 22, so I could do 20 and 22. And then those would be my two sets of integers. Okay? So again, using that number theory, figuring out what the first integer is, and then what is the next integer to get where you're going. Let's look for the last one that we're going to do somewhat together is number 9. Right here. And it says the golden ratio appears in the design of the Greek Parthenon because the width and height of the facade are related by the equation w plus h over w equals w over h. If the height of the model of the Parthenon is 16 inches, what is the width? Round your answer to the nearest tenth. Well, I've got this equation, w plus h over w equals w over h, so it tells me that the height is 16, so let's just plug in 16 for h. So I have w plus 16 over w equals w over 16. And now you're thinking, what in the world do I do with this? Well, we've got a proportion set up, and remember when we're trying to solve proportions, we cross multiply. So I'm going to start with w times w is w squared. And then I'm going to do equals 16 times w plus 16. Okay? Now, let's do the distributive property. W squared equals 16w plus 16 times 16 is 256. Now, I'm going to create a trinomial. W squared minus 16w minus 256 equals 0. It doesn't matter to me how you solve this one. You could try to come up with two factors of negative 256 that equal negative 16, or you could use the quadratic formula. It says round your answer to the nearest tenth. That usually gives me a hint that I need to use the quadratic formula. So I'm going to stop here and let you finish it however you want to, and then you can count this as one of your 5. So, hopefully that has helped clarify a few things about how to solve quadratic equations in word problems.